So just a reminder, I'm the president of the SCSI Trade Association. And now that we're part of SNIA, it's called a forum, so I'm the forum chair. I also wear the hat of marketing work group chair for MVM Express. So for SAS and NVMe, I wear, I basically represent the same group for both. And as Fred mentioned, I have a few slides on AI as it relates to storage technology, in particular, most likely SSDs. And so that's going to be more of a kind of a discussion. I would love to get your input and feedback on some of the things that I have on the slides. So I'm not going to repeat what I showed last year, but I do have a couple of updates. Just from an agenda standpoint, the top one is, okay, for those of you who either don't remember or were not here last year, I have a one-slide reminder of what the STA Forum is. SAS Connected Storage, this is basically, it's an update from market data. And then it gets into what is news about SAS, because what's happened over the past year, anything interesting. So we have had a couple of events, which I'll go into a little bit of detail, and then SAS is going places. That's kind of a fun one. And then what's going to happen next? So this is the one page that was the same as last year. SCSI Trade Association Forum is a part of SNIA, and it's basically the marketing arm for the T10 committee, which develops the SAS and SCSI standards. The group is made up of, about 13 companies plus the University of New Hampshire's interoperability lab. So there's a total of 14. And still active, and SNIA has gone through a membership level kind of reorganization. So basically, in a lot of cases, they're reducing prices to join SNIA. Once you join SNIA, you can join any group within SNIA. So this hopefully will grow by the time you see this next year. Okay, this is the update from last year. This is trend focus data, and this is just looking at the capacity of SAS connected storage. The vast majority of it is nearline hard drives, and since SAS can talk to SATA as well as SAS hard drives and SAS and SATA SSDs, since it is mostly nearline SATA, a lot of this is really just kind of archive and cold type of data where you don't need SSDs. Just another look from a bar chart standpoint. Again, this is focused on the enterprise. So this was updated from last year. We didn't have 2028, and you can see that the capacity is still growing. And that's trend focus data, but also IDC still has SAS continuing to grow. Mainly again from a hard drive perspective. So that's all like the repeat and slightly revised slides. So if you remember last year, we had a couple of fun quiz questions. So a lot of you should be familiar with the storage and memory pyramid, where the really fast and expensive stuff is at the top, and then the cheaper media is at the bottom. So where does SAS play in the memory storage pyramid? All right, SRAM is in the CPU. We all know what DRAM and storage class memory is, and then of course NAND, hard drive tape, and handwritten paper. That's just one thrown in there. It's an easy one. You don't have to. That's not an answer.
Handwritten paper, then copied to an image.
Oh yes, you could take a handwritten copy and then take a picture of it and throw it onto any of these mediums.
My wife used to deal with stuff that was important stuff was the notes in the margin by her boss, who was the leader in whatever it was. So they had to have the images because they had written notes in the margin. What's important.
So that technically that probably is true. Then this is on handwritten paper is logged on some of the, some other. So this is multiple. Any thoughts on which of these items does SAS play? Tim.
I think let me take a wild stab at just anything just below. I was going to say, do we have any examples of SCMs on the market now that Octane is dead? Are we ever likely to now?
Well, I'll have to put my Kioxia. I work for Kioxia as disclaimer as my regular job. Kioxia has and
Single
storage
flash as an SCM.
single. Yeah, basically it's.
Is that really an SCM? Okay, sorry. Complete diversion. Please ignore me. Fred, forgive me. I'm sorry.
But
Sorry, Cam. Does everyone know what this? Because to me, it looks like I don't know what it looks like, but is everyone familiar with each one of those?
Yes, we do that.
So just me. Okay.
No, but CXL means too early.
yes,
I don't know
yeah.
paper.
Octane could have had a future. But I mean, the Kioxia solution, which is called the FL6, is a single level cell.
Yeah. It's
Yeah,
flash.
yeah. It's single high performance, high endurance flash, and it is cheaper and it does work in a SCM type of environment. So it does exist, but obviously Optane is no longer. So
We just get lots of DDR4 and stick batteries in.
yes, that's an expensive solution, but yes, that can be battery backing DDR has been done.
There's a lot of old servers with DDR4 that are being decommissioned, so there's a lot of DDR4 available to put into
Right.
essentially CXL expansion boxes. And the EU now has a mandate for a certain amount of refurbished equipment to be
Oh,
purchased as part of the infrastructure. So there's
there's a new industry right there. Okay. Anybody think it's in SRAM? DRAM? SCM? SSD?
Well, yeah.
HDD? Tape? And handwritten paper? Yes, if you take a picture of it.
We've got punch tapes.
Yeah, we don't have punch cards. That's true. So basically, SAS technology connects to tape, hard drive, and SSD/NAND. So, and you can see, from the storage perspective, it connects the largest portion. So, I mean, that's just kind of a fun FYI. The SAS Technology Roadmap, this is slightly different than last time. We did mention that 24 gig was coming, and we did an announcement earlier this year, and there's basically 24 gig plus is a set of features. It is not a speed bump. Honestly, we're not sure if there's going to be any more speed bumps. But similar to NVM Express, it's basically settled into kind of a feature enhancement as opposed to doing anything drastic around performance. Of course, NVM Express rides upon PCI Express, and so the speed bumps will come with NVMe. But as far as the future of both NVMe as well as SAS, it's mainly kind of feature focused as opposed to anything major changes. So I do have.
Excuse me, I'm sorry.
Yes, sir.
At the moment, SAS is a communications protocol and a wire combined, isn't it?
Yes.
Could you separate the two and have the communications protocol taking place across another wire?
Like PCI Express. So if you didn't hear Chris, the question was kind of separating the protocol and the transport of SAS. So you have the SAS commands possibly sitting on top of another transport like PCI Express. Fun fact, some years ago, back in probably 2010, there was an effort called SCSI Express. And it was doing exactly that. The proposal was, this was right when MVM Express was being formed and coming out. There was a proposal, and I was actually part of that, to create a abstract the command set protocol and put it on top of PCI Express. And it passed and work started being done, but due to some shifts in the, I'll call it political landscape of technology, meaning enough people jumped on the MVM Express bandwagon, everybody went full MVM Express as opposed to working with the SCSI commands on top of PCI Express. So SCSI Express went by the wayside, but that's a very good thought, Chris, and there is a history there.
But no future.
There is no future. Well, if you look side by side between NVMe and SAS from commands and features and general capability standpoint, they're similar. All right, the rooted architecture and the circular queues and the number of queues and queue depth for NVMe, way more advanced than SAS. But if you look at some of the capabilities, like the reliability and scalability and fault-tolerant things and security, they're in both. NVMe leveraged from SAS, and actually SAS is leveraging from NVMe now.
But the idea of having NVMe used to interface with disk drives seems to me inherently ludicrous.
Oh,
It's like putting a Ferrari steering wheel in front of a large truck. Why bother? You've already got a great interface, so better put SAS on the PCIe bus.
It's more
All
fun.
those existing disk drives, we should just slot straight in.
Yeah. I was for one sad that SCSI Express did not go, because I was very much in the SAS space. But to Chris's point about, well, now if you want to have a homogeneous environment, you'd have to put hard drives with a PCIe interface, and putting a small engine in a Ferrari is not a good idea. The latest on that, I know that Seagate has an NVMe-based hard drive. I don't think it is getting widely adopted. But I think as long as there's hard drives that need to be connected, at least for a while, it's going to be connected through SAS expanders. So basically SAS technology will be around because of hard drives for a long time. So I have one slide that goes into a little bit more detail about this, and we'll look at the benefits as opposed to going into the nuts and bolts of things, because I think the benefits is what you guys and your readers mostly care about. And then probably for the next generation of 24 gig plus, whatever we end up calling it, there are some additional features that are under consideration. Yes, sir.
Dumb question. But I think I know what plugfest means, but what does it actually mean?
So he's referring to, plugfest is the leading edge. A plugfest is a test event. And that's actually a good lead in, because I'll have a little bit more details on the 24 gig plugfest. But basically, it's a very important part of why SAS technology was very successful, is because the vendors got together and did these plugfests at multiple levels, from a device level to very large scale systems, and they work out the problems before customers get together.
Checking interoperability.
Yes.
So it's not, we don't want standards, we want interoperability.
Well, one of the things about standards is that there's always things are going to be interpreted differently by different people. And if you interpret it slightly differently, then it could be implemented differently in your products. And that's what these plug fests will help vet.
I remember going to that with STA when the standards interpreted differently and testing it out on the users.
Yes, yeah. So we try to test them out with each other as opposed to testing out the user, having the users test it out. So this is the 24 gig, that same little set of features. So these are the list of things that are under consideration, as well as what we're calling 24 gig plus. Bunch of words, but really it comes into the benefits. Command duration limits, better support service level agreements, format with presets, whatever that means. It helps with the reduction of end SKUs, and so you don't have SKU proliferation. It improves rebuild time for RAID systems. RAID is a technology that is really ancient. I think it was born in like 1990-ish with the RAID paper by Garth Gibson, yeah. So RAID is still around. What's that?
Randy Katz.
And Randy Katz, yes.
Don't forget Randy.
Berkeley and Carnegie Mellon. Reduce overhead and higher performance. More connectivity out of a low-profile board, adding compatibility with copper-link cables. So this is kind of a cable compatibility. So future ones, improved security, improved reliability, improved quality of more quality of service, for SAS devices. So I mean, what this really, the message here is that there's still development efforts going on to improve the use of SAS in hard drives and SSDs, whether it be SAS or SATA. One of the maybe little known things about SAS is that one of the definitions or the mantras is that you go back 2 generations. So 24 gig SAS will support 12 and 6 gig devices, SAS and SATA. So that's another reason why it is still used, because it'll work with 6 gig SATA hard drives. All right, I'm not sure why the font changed. I think it's meant to look a little bit more technical. Yeah, it's supposed to look like a command line interface or something. Here we go. But the question about a plug fest, back in April, there was a 24 gig SAS plug fest, and basically it tests a multitude of ways: basic link up, power management, cables, and timers to make sure the signals arrive at the proper time. So the basic link ups are going to be very kind of point-to-point type of connections, making sure that they're able to basically to sync and appropriately work at either 6, 12, or 24 gig. One of the big things, and I have a slide, the next slide kind of shows what a large topology build is. It's a mix of all these 3 generations, SAS and SATA hard drives and SSDs, various types of cables, enclosures, expanders from multiple companies, host bus adapters, and then the testing companies like the analyzers. And through the last one, in the large topology build, an issue was identified with managed cables. And at the Plug Fest, the participants were able to resolve the problem fairly quickly. And so when when these products get to customers, they will work properly.
What was the issue?
Well, it was an interpretation of the standard.
Okay.
So the problem is that some people interpreted it slightly differently, and they deployed it or implemented it a little differently in their products. Through cooperation at the test event, they were able to figure out a way to resolve it. And just to take a look at the large topology build. So here, none of the vendors are ever called out specifically, but you can look at the list of who participated, so you can kind of figure out who's who. But 24 gig SAS, 12 gig SAS, 24 gig SAS SSDs, again from multiple vendors, multiple products. 12 gig SAS hard drives, 6 gig SATA hard drives, expanders, so there's so two different expander companies and an enclosure company, passive enclosure with no expander, copper cable, 1 meter, 3 meter, 100 meter active optical, 30 meter active. So you can see the variety and combinations that what a plugfest will do. And so this is likely to test the vast majority of cases that any customer would implement. Okay, now for the fun one. Where did SAS technology go earlier this year?
The 3D form factors.
All right. Well, it'll have gone to Hawaii if somebody brought their server with them. International Space. So you're guessing Internet ISS?
Yes.
Okay. Elon Musk's XAI data center. Any takers on that? CXL module? E3.S? How about E1.S? Okay. Well, there is only one correct answer, unless you brought a server to Hawaii. It went to the International Space Station, but not with Seagate.
Yeah.
Yeah, so if you recognize this logo, it's Hewlett-Packard Enterprise. The company that I worked for, Kioxia, gave our SSDs to Hewlett-Packard to put into their Spaceborne Computer 2 refresh. And these are redundant servers. And it went up on January 30th. The NG-20, which is just the name of the mission, is basically, it's a Northrop Grumman Cygnus storage pod that sat on top of a SpaceX Dragon rocket. That's the first time that they've ever worked together to launch. And the reason why Northrop Grumman didn't have a rocket to use is because their rocket engines are manufactured in the Ukraine. So I think it may not exist right now. So through cooperation with SpaceX, the Northrop Grumman storage module basically brought the servers up to the ISS. So this is launch, this is separation, and this is the landing of the Dragon rocket module. So just to look at the hardware, the Hewlett-Packard sent up an edge line. The Hewlett-Packard Spaceborne Computer 2 servers include an Edgeline 4000, which included some M.2 SSDs. And then it went up with 8 SAS drives. So 4 value SAS drives. If you're not familiar with value SAS, it's a single port, kind of lower cost, meant to compete with SATA. And then enterprise SAS, and it went up with 4 30 terabyte drives. So if you combine, it's over, I think it's, well, the grand total is almost 130 terabytes of storage that went up. But just with SAS technology, 124, 125 terabytes of data storage went up in an HPE DL360 server. So these servers are done to have been sent to conduct scientific experiments. The edge line is a edge server, as you can probably figure. There's a lot of kind of real-time experimentation going on, and the drives are being monitored on a daily basis for health, and so far there have been no issues with the SSDs. But that's where SAS went.
What do you think about cosmic phase and things up there? Because I thought that you've got particles zooming through the space station energy, which I thought would disrupt memory.
So I guess the comment is, with being up in space, it's going to be exposed to radiation and cosmic rays and things like that. The purpose of the Spaceborne Computer 2 was designed to take commercial off-the-shelf components. So just a regular server that a typical customer would buy, and with the SSDs that went up, the SSDs were not treated or modified in any way. They are just off-the-shelf standard SSDs. And so far, there have been no failures. So the whole one of the goals of this Spaceborne Computer 2 project is to see how commercial off-the-shelf components will fare in space. And so far, so good. No bit flips, nothing yet. But they have measured, like with the with the sunbursts and stuff like that. They do measure a lot more radiation coming through. But so far, this is just SAS. Some of the things that you can check out. And I think in the slide deck, I think we'll provide a PDF that has a link to each of these, so these should be clickable links. So Dr. Mark Fernandez is the lead investigator from Hewlett-Packard on this, and he and I did a podcast. So we did a video, a podcast, and this is just a 1-minute video, which is really cool, about Dr. Fernandez talking about SAS technology and why it was chosen to be used on this ISS mission.
Can you say why?
Well, why? So why SAS? At the time that the components were selected, 30 terabytes was the largest capacity. So, and we did not have an NVMe drive that was 30 terabytes at the time. So one was capacity. Value SAS was chosen because it will give you good performance at lower power. So it's a combination of power and capacity with good enough performance. For in the DL360, these are using SAS drives and 10 gig Ethernet. So I mean, it's not a super high performance system, but it is designed to run experiments, and so far the experiments have been successful. Does that answer your question?
Yes.
Okay. About why SAS? So SAS, again, there's some cool things. Is anybody familiar with a YouTuber named Linus Tech Tips? So Linus did a full video with the ISS mock-up. And so he kind of went into a lot more detail about the overall server program. And interestingly, at the very tail end of it, he kind of pans out, and then there's a couple people standing in the shadows, and I'm one of them. So I got to be in the video. So what's happening with SAS in the future? Okay, no performance speed bumps expected. There are features that are planning to be added, and they're going to be focused on what we call the ilities: reliability, scalability, interoperability, serviceability. Those are the ilities. But then you have security, which isn't an ility, but But security is one of the things that will be. And then with the rate at SAS connected capacity is growing, it's going to have a very long tail, and most likely SAS will be around a lot longer than we will.
Security, trustability.
I'm sorry, what? Oh, trustability.
Yeah.
Yeah, there we go. Unless we can make a security ability. Yeah, and we just had this here, storage newsletter, repurposed a press release around our 24 gig SAS press release. So that's something that was, I guess to the best of my knowledge, might have been what was covered in the European press about the press release.
Any questions so far? No?
When was this press release?
When was this press release, Cam?
In April?
Yeah, the Plug Fest was in April. I apologize, I don't remember. It's somewhere around there.
I think you're a bit more positive about the outlook of SAS than last year, if memory serves. The SAS will be around longer than we will. I think last year we were more like, oh, it has some legs, there's some more life in it, but not entirely sure. What changed?
Well, one of the things is that SAS connected capacity is growing. And I mean, until it starts declining, that tail is not really going like this. It's definitely a slower slope. And hopefully SAS will be used in other kind of unique applications or interesting applications. Once a product gets used in space, there's a classification called TRL, Technology Readiness Level, and it goes from 1 to 9. 1 is basically like a specification, and 9 is actually being used and deployed in that environment. And SAS SSDs and the other SSDs that are on the ISS are the only ones that are TRL 9 that are successfully being used in space. So given that they're the only, SAS drives are actually being used in TRL 9 in space, that may give them more legs for other people who are deploying servers in space. They know that these drives will work. So far, so good. I mean, everything went up at the end of January, and everything went online in, I think, end of February, early March. So far, so good. They're being monitored on a daily basis, and so far, no issues. So I had a similar slide last year, and I think I updated the first and third bullets where SAS continues to be an integral technology for storage from small, medium business, enterprise, hyperscale, and space. This is more the ilities, the flexibility, reliability, and scalability. You still make it a viable technology, but it's not going to be your highest performance product. I think everybody knows that. And use of SSDs is on the decline, but hard drive use is continuing to grow, actually. So, and it's evolving to meet the needs of data centers. I think one of the things that I pointed out last year is that it was part of an open compute project specification, Grand Canyon, 24 gig SAS expanders, because they connected a bunch of hard drives in there. So it's being used in hyperscale as well. So, there's places where SAS is finding a home. But when everybody thinks that typical kind of mainstream, high-performance, server-oriented type of SSD, I think we all know that NVM Express is the technology for that one. This is my last slide on SAS. Any questions about SAS?
Yes, please.
Yes.
Cameron, when it comes to the future, planning, the feature to be added? What is the process?
Well, probably one of the most simple processes for adding new features into SAS is leveraging new features going into NVMe. A vast majority of overlap of the standards bodies people are on both NVM Express as well as SAS. And a lot of companies still have products that support both technologies. So if there's something developed under NVM Express that makes sense to be ported into SAS, it will be done. And some of the features that were in the 24 gig plus list are exactly that, leveraged from NVM Express. And probably the other is going to be any hard drive specific capabilities. Like if there's any new developments in hard drive technology that need a help from the specifications for SAS, then it'll get implemented that way. So hard drive developments and things from NVM Express.